figuring out how many total seats were in this concert hall. But then we have a revision. So part C says, what if 12 more rows are built or added? So if I add 12 more, so remember I had 32. That means that my end value changes to 32 plus 12. So go ahead and see what you get when you add 32 plus 12. So now we have 44 rows. What do I need to know in order to find the sum of 44 rows? I need to know T1. And what else do I need to know? For arithmetic sum, go ahead and look at your formula. You need to know the first and what else? The last. But now my last is 44. So you need to figure out what T44 is using the general rule that you wrote in part A. So 25 plus 43 is what? 25, 33. All right, who got 68? Okay, so now the sum formula, this is arithmetic because I'm adding, they're adding one seat. So we're using the arithmetic sum formula. So the sum of these 44 rows will be 44 over 2. Multiply that by how many seats are in row 1 plus how many seats are in row 44. So go ahead and figure out what your new total is. Okay, but we still didn't answer the question. You always need to go back and reread what they are asking for. The question is, how many additional seats will this new concert hall have? So what do I need to do with my answers for part C and part B? You need to subtract them. Go back and make sure you are answering the questions. So that would be 2046 minus 1296. Thank you. Thank you so much. Do you have your pass?
Yeah.
You want me to sign it? Or are you good?
I'm good.
Okay. So that would get, I think it was, wait, I don't remember. I think it was 750. Was it 750 or 650? 750. So there are 750 more seats. So by adding the 12 rows, they added 750 more seats. Any questions? All right, so now let's go to geometric sum. If you weren't here yesterday, go ahead and copy down this formula. This is on page 11. So this is formula number 4. All right, in order to find the sum of a geometric sequence, you need to know the first term, what are we multiplying by, and the common ratio. Those are the 3 things that we have to know. Now, I want you to realize that now this formula looks a little ugly, but it is T1 multiplied by this fraction. The fraction is 1 minus r to the power of n divided by 1 minus r. Okay, so when you see this rule, remember that the sigma means sum. So if it's a sum formula, how do I know this is an arithmetic sum and not a, wait, how do I know if it's arithmetic or geometric? Looking at the rule. What do you notice in this rule that tells me it's geometric? Exponent. All right, go ahead and write that down. If your rule has an exponent, that means that it is geometric. So because it's geometric, this is my geometric general rule. So remember, in the geometric general rule, it's T1 times R to the power of n minus 1. So the three things we need to know. I need to know my first term, which would be 5. See how that's the first number, right? That's because that's my rule. So T1 is 5. My common ratio, that's the base of my exponent, that is 3. And then how many numbers do they want me to add? This says we're going to start with the first one and end with the 5th one. That's what that tells you. Remember, this at the bottom of the sigma tells you where to start. And this tells you where to end. So n is 5. So, all right, so let's go ahead and do it. So we're going to, the sum is going to be 5 times, make your fraction bar, 1 minus r to the power of n over 1 minus r. All right, go ahead, type that in your calculator, see what you get. Okay. All right, what did you all get? Wait, what? 605. Who got 605? All right, so I want to make sure we all understand what just happened here. That's the sum. Okay. So now I want you, just one time, I want us to do it the long way because I want you to understand what we just did. So we figured out that the sum is 605. Okay, so it's only 5 numbers, so let's go ahead and do it. Let's make our 5 blanks. So I'm starting with 5. I want you to multiply by 3. Multiply by 3 and get the next 4 numbers. Just for this one. So pick up your calculators and multiply it by 3 to get the next 4 numbers. All right, who got that for the 5 numbers? Now, I want you to add them up. Add up these 5 numbers. And you should get 605. That's what the geometric sum is saying. Take the first 5 numbers and add them together. The geometric sum is 605. Any questions about number 1? All right, let's look at number 2. Number 2 is where it gets a little tricky. Our first number is 2. I'm multiplying by negative 1.5. And what is n? 8. All right. So we got it to find my sum. And it's geometric because there's an exponent. When you take your test, it won't say if it's geometric or arithmetic. You have to know, looking at the rule, if it's geometric or arithmetic. If you see an exponent, that's multiplication. Okay, so the sum is going to equal the first number multiplied by 1 minus, now I'm going to put this in parentheses, negative 1.5 to the power of 8. That's all over 1 minus negative 1.5. Okay, why is this the question that half of the students miss? It's because, what do you think? That they changed this double negative to an addition. Now, I agree. When you subtract a negative, it is addition. But notice in the numerator, what is attached to this? An exponent. Remember, PEMDAS. What do you do first? Do you do an exponent or you do subtraction first? Which one comes first? Exponent. So you do not want to change this to a plus. Don't change it to a plus. You could change the bottom to a plus, but definitely you cannot change that to a plus. So go ahead, type that in your calculator. Take your time. Use parentheses. Use the negative. Use the fraction button. Okay, so you should get, and I'm just going to round it to the thousands place. If it doesn't tell you on the test where to round to, then I'm not going to take off. Like, it doesn't tell us on this where to round to. So if you put negative 19.7, that's fine. But to the thousands place, it would be, the sum is approximately negative 19.703. So when you subtract, you have to use this, and when it's a negative, you have to use that. It looks like you use subtraction twice. Yeah. Did it work? Okay. Now let's look at number 3. Number 3 and 4 are what we call partial sums. What do you notice that's different about number 3 compared to number 1 and 2? Where we start. Yeah, this one doesn't start at the first number. Where is it telling me to start? The 5th number. So this is telling me to start with the 5th number and end with the 10th number. Now the problem is I don't know T5. So I need to find my T5 first. Go ahead and substitute a 5 in right here. Because now I need to know T5. I don't need to know T1. So the sum formula that I'm going to use will be the sum. And then instead of T1, it's going to be a T5. 1 minus r to the power of n over 1 minus r. All right, so let's figure out what T5 is first. So T5 is going to be 2 times 4 to the power of 5 minus 1. So I'm going to give you a second. Figure out what is T5. Type that in your calculator. Alina, what you get for a T5? What you get, Josie? 512. You need me to show you how to type it in? You know how to type it in, Alina? Okay. So that's my T5. Okay. So T5 is 512. What am I multiplying by? What's the common ratio? What's the base of my exponent? the base of my exponent. Going back to your rule, this is the base of my exponent. That's my common ratio. So what's my common ratio? 4. Okay, now here's the tricky part. This is the question that most people get wrong. How many numbers am I adding? I disagree. It's not 5. I knew you were going to say 5, but it's not 5. So what I'm going to do, I'm going to write the numbers 5 through 10, and then count how many numbers you write. If I start at 5 and I count up to 10, there's 6 numbers. There are 6 numbers. When you subtract, you don't include the first. But I need to include that number. I'm adding the 5th to the 6th to the 7th to the 8th to the 9th to the 10th. So n is 6. Okay, let's find our sum. So we got 512 times 1 minus 4 to the power of 6 all over 1 minus 4. All right, does anybody have any questions? I want you to try to do number 4 by yourself. Okay. I don't remember the answer, so I'm going to just kind of look. Oh, yes, I do. Now I remember the answer. Oh, you round it. You can't round that. Yeah, she won. Yeah, don't round T1 because that's gonna put the 175. Okay. So this one is telling me to start where? Where do we start for number 4? We start with the 3rd number and we end with the 5th number. So we need to find T3. All right, who got 1.75? Okay, so then my common multiplier, my common ratio is 0.5. How many numbers am I adding? If I start at the third number and end at the fifth number, how many numbers would that be? 3. All right, so the sum is 1.75. Multiply that by, actually, let me move it down so I can fit it. All right, so the sum is 1.75. Make your fraction 1 minus r to the power of n over 1 minus r. And I know it's like 3.06, and then it's a couple numbers after that. 25. That would be my sum. All right, questions. All right, last formula. Let's get it started. We probably won't finish it, but now let's talk about the fifth formula. The last formula is an infinite. I'm going to rewrite this. If it's an infinite sum, so this is all 5 formulas. I got them written on the board. Those are the 5 formulas for the next test. If you need flashcards, I have flashcards. Okay, so do you agree? Well, first of all, it converges if the absolute value of r is less than 1. So if my common ratio, and I'm talking about the absolute value, is less than 1, that's what this means. It's going to converge. And what that means is it's going to approach 0. That's what that's saying. Do you agree that if I multiply a number by let's say 0.5, if I keep taking a number and I keep chopping it in half, do you agree that the number is getting smaller and smaller and smaller? And eventually it's going to get really close to 0. All right. If it converges, then we can actually find the infinite sum using this formula. Only if r, the absolute value of r, is less than 1. Now, if I'm multiplying it by something greater than 1, so let's say I'm taking a number and I'm doubling it. My number is getting bigger and bigger and bigger. It's not going to ever plateau. So it is impossible to add up and find the sum of a series that's approaching infinity. So if your r value, if this r value is greater than 1, you would simply tell me on the test that it has no sum. It does not have a sum. So we only use this formula only if the absolute value of r is less than 1. And the reason why we have to focus on the absolute value, if you have a negative 2/3, then we're really focusing on the fact that it's 2/3. And because that's less than 1, it will give you a sum. All right, so these are our last 2 for today. So let's looking at this first one here. How do I know that this is an infinite sum? It doesn't tell, it does say it, but it won't say it on the test. What do you notice on my sigma that tells me that they want an infinite sum? Yes, notice that it says it's going to end. It ends at infinity. Okay, looking at my r value. R is 3/2. Is that greater than 1 or less than 1? Who says greater? Who says less? Anytime the top number is bigger than the bottom number is greater. All right, this is the same as saying 1.5. So because r is 1.5, this has no sum. There is no sum. R is bigger than 1. You cannot do a formula. The answer is NA. There is not one. But looking at B, my R value is 1/5. Is 1 over 5 less than 1 or greater than 1? Less than 1. So we can use the formula. So the formula says, it's pretty simple. All you have to do is take the first number and divide it by 1 minus r. That's your formula. That's your last formula. So my r value is 1/5. T1 is -5. So this one does have a sum. So my sum is going to equal -5 divided by 1 minus 1/5. Go ahead and type that in your calculators. -6.25. Or anybody write it as -25 over 4, either way. Or -25 over 4. All right.